But it's not just about volcanoes causing climate change. It could well be the other way round. Bill Maguire again.
In September 2009, we held an international conference at University College London looking at how climate change can force geological and geomorphological hazards, in other words, how it can cause them. Papers presented at that meeting have just been published online. One of the papers in the volume addresses Iceland, and it looks at what will happen when the Vatnajökull ice sheet melts, which it will do if emissions are unmitigated, if we carry on as we are at the moment. And they forecast an increase in volcanic activity and actually more magma being produced in the mantle, as well as this ice is lost and the crust starts to come back up again and the pressure is reduced within the crust of the mantle. But there has been some speculation that earthquakes in places like Alaska are already the result of melting ice. Some of the glaciers in Alaska have melted enormously. They've lost a huge amount of mass, and there have been a number of peer-reviewed papers in journals suggesting that some of the seismicity in Alaska, some of the earthquake activity, is a result of this ice mass loss. So we could already be seeing the start of this response. The thing is, we really don't know how long it's going to be before we see more volcanoes erupting, more big earthquakes happening, submarine landslides, this sort of thing, or if we ever will do. And we also don't know if there'll be a linear response, if we'll gradually see more of these events, or if we'll get to thresholds or tipping points where all of a sudden we start seeing more volcanoes erupting or more earthquakes in coastal locations or something like that. It's very, very difficult to say.
Hazel Reimer of the Open University.
There is evidence that since the last ice age, there's been more activity in Iceland because the weight of the ice has been being lifted as the ice caps have retreated on Iceland, and that's reduced the pressure on the magma underneath. So there is evidence that there has been an increase in activity since the last ice age. So on very broad timescales, you do have local increases and decreases.
Well, we know that big changes in climate in the past are linked to big changes in hazardous activity, geologically hazardous activity. So more volcanic eruptions, more earthquakes as well, as ice is lost from as the ice sheets melt and the crust pops up again, that generates more earthquakes. Those earthquakes can trigger submarine landslides and have done in the past. Those landslides can trigger tsunamis, and they have done in the past as well. So we have this whole range of geological hazards that are triggered at times of rapid climate change. And the question is, in the current episode of climate change caused by human activities, are we going to see the same response? Are we going to see more geologically hazardous activity? If we are going to see it, how quickly is the response going to occur? And exactly what will we see?
Bill Maguire's recent paper suggests we may face more natural disasters like volcanic activity. Climate skeptics may argue that this is amongst the most far-fetched ideas of man-made climate change, but Bill believes there is irrefutable proof in past events.
The mechanisms are robust. I think they're quite straightforward, and in terms of volcanoes, we can look back in Iceland at a time when Iceland was completely covered in ice and there was very little volcanic activity. And then as the ice sheets melted over the last 20,000 years, 20,000 to 10,000 years ago, there was a very big increase in volcanic activity because of the reduced load of the ice. So that's a well-established effect. Now, of course, there was a lot more ice on top of the volcanoes then than there is now. But it is modelling has shown and has projected that if the Vatnajökull ice sheet does melt, then we will see a similar response, if on a smaller scale. So the mechanisms are there.